questions from our sets lab yesterday. Yesterday we got introduced to sets, the third collection in the Swift language. We saw arrays, we saw dictionaries, and yesterday we saw sets. And we were posed with some questions to go ahead and practice. Of those two questions, we pulled two of those questions and reviewing them today. Question 2 from the lab asks, create a new array, scores that appear once, that has all the elements from scores that appear exactly once. It should be in the same order as the original, right? So we have an array here called scores. We observe the array. We see there are duplicates there. So basically, the answer of that particular question, as we see on line 14, the output should be an array with two elements, right? Those elements only appear once. The number 1 appears once here. The number 99 also appears only once in that particular scores array, right? So, reading the array, if we actually just go ahead and read the array from the way it's laid out, we go through it from index 0, we see 1. Do we see any 1 until we get to the end? There's no other ones, correct? We see 77. That's one time it appeared. We keep going, 83, 32. We see 77 again. So at that point, do we add 77 to our final array? We don't, correct? We go to 83. We saw it once. It appeared once. We keep reading. We see it again. Does it appear in the final array? No. 32, same thing. We see it again. 77, we saw it before. So if we've seen it before, or we've seen it again, we do not add it. We only keep that final array if we only read that value once. So far, so good? As a human being, we could go through it, and we could see at the end, we only saw 1 once, appear once, and we only saw 99 appearing once. So this is great. As a human, we know what's happening here. So we need to make the computer basically simulate what we're seeing, right? We know how to go through an array using a for loop. So far, so good? We know how to create variables to keep track of things, right? And we know how to look to see if something exists in a set by using contains. Everybody with me? So we basically have the tools we need to solve that problem. So the question is, how do we start? Right? One way to start, you could diagram it out, like the procedure. How can we go ahead and do that problem? Right? Step 1 is to iterate through the scores. That makes sense. I want to read all the scores. Does that make sense so far? I want to use a for loop to go through scores. As I go through scores, I want to keep track of what I'm seeing. Have I visited number 1 before? In that case, have I seen number 1 before? Have I seen number 1 before? No. So I add it to some variable. Everybody with me? I add it to my bag, to my bucket, to my collection. I add it to the collection I'm keeping track of. As I keep reading, have I seen 77 before? So I add it, right? I've seen it. Great. 83, same thing. I haven't seen 83. Add it. 32, go ahead and add it. 77, have I seen 77 before? So at this point, I want to remove it from whatever I was tracking. Everybody with me? I keep going. At this point, does 77 exist in what I removed? No. No, right? So we need a way to be like, hey, I've seen this variable before. I've seen that number before. So we need to have some sort of way to say, hey, I've visited this coffee shop. I'm not going to go there again. I don't like the coffee. It's burnt, right? So I need to keep a way to keep track of what I've visited. My visited set or array, whatever, should not be touched, right? It's only there to see what I've seen before. In that case, I've seen 77, so should I add 77? No, right? So we keep going. 83, same thing. Have I seen 83 before? So I do not add it, correct? I only want to add things I haven't seen. If I have seen it, I want to remove it. To 32, same thing. I've seen 32 before, correct? Should we add 32? No. 99, have we seen 99 before? Should we add it? And we're done. At the end of the day, we should have some sort of set with 1 and 99 based on what we spoke about here, right? So in an interview, you talk about your process. We haven't done any coding. You talk about your process. You write your steps on a whiteboard. Tomorrow, we'll start going through how to do that together. You write your steps. Those are the steps. I want to look through the array. I'll have some variables to keep track of things I've visited before. You could actually write it as we said it there. If I've visited an item, I want to remove it from my final array, right? If I haven't seen it, add it. If I've seen it, remove it until I get to the end, right? When you get to the end of your pseudocode, whatever, test it. Test it as we tested here. If I go through that array, is it valid, right? Does it work? It does. So at this point, you're ready. You tell your interviewer, hey, I'm ready to code. Can I go ahead, right? Because you've asked the clarifying questions. There's no ambiguity with the question. You clear with the test cases you've done, right? So now you're ready to code. As you code, you might come across certain cases where, oh, I have an error here. You fix it, that's fine. That's part of coding. But the general logic, we have it so far, correct? Correct? Okay, so let's start coding. What's the first step we said? We need to go through scores, correct? And what are we using for that? How do we go through scores? Right, so we'll use a for loop. We'll say for score in scores. Great. So here we could see a score. But we said we need to keep track of what we visited before, correct? Everybody? So we'll create some set here called visited scores. It's a set of integers. It's empty currently. So far, so good? So far, so good. Here we've declared a variable. It's called visited score or scores. Visited scores, it's a set. We type annotated it to say it's an integer array or integer set, sorry. We declare that it's empty with the empty brackets here. But we also need some sort of bucket to keep the scores that we actually add into. So far, so good? So we'll create a new set, call it unique scores. It's also empty. Yes, sir? Say that again, I'm sorry. We'll come to that later, right? We'll come to that as we refactor the code. Part of it is getting to the solution and refactor as we need. Cool? All right, great. So let us keep going here. Great. So now we go through our for loop. That's great. And we could start writing the logic that we spoke about. If we haven't visited it, we'll insert it. Everybody with me? That's the code we need to write. If I haven't visited a score, go ahead and add it. So let's write that in code. So if, right, visited scores dot contains my score. In that case, we want it to be the opposite here, right? So if I haven't visited a score, that's what this logic says. The not here says not true, right? If I haven't visited scores, we haven't seen it, right? Haven't seen the score, all right? If I haven't seen the score, I want to go ahead and add it, correct? I want to insert it, yes or no? Yes or no? Okay. So here we'll say visited score dot insert the score, right? So now we're keeping track of things we've seen. We also want to add it to our unique scores. Right? So unique scores here that insert score. Great. So if I haven't seen it, go ahead inside my if statement, add it to visited scores. Right? If I have seen it, what am I doing? If we've seen score before, what are we doing? Ignoring it. If we have a score currently in our bucket, right? I'm going through my array, right? At this point, I have seen 77. I added it to my visited scores. I added it to my unique scores, right? I come across the second 77. What do I do in that case? Everybody with Christian? Christian says to remove it. Do we agree? Do we agree, Chelsea? You don't agree. We should not remove it. Oh, you don't know what I'm asking. Okay, that's fine. So scenario number 77. What happens to 77? Do we add it the first time we see it? We add it, correct? So we come inside our if statement, we add it here. So far, so good? When we see 77 again, what do we do? The question, go back to the question, right? The question says, we only want to add elements that appears once. Unique is 1, right? So in that case, 77 appearing 3 times, does that make it unique? No. So what do we do? Do we add it to our end result, or do we remove it? Okay? Okay, good. Everybody on board here? Right, so the next time we see 77, we want to remove it, correct? Yes? Okay, so let's go to an else statement here. Right? So in that case, if we haven't seen it, in our else, that means we've seen this value. Or visited this value. So it's not unique. Everybody agree? Okay, so here we will say, go ahead on my unique scores, remove it. Cool? So at the end of that for loop, we're pretty much where we want to be based on the pseudocode and what we spoke about, right? We visited an array. If we've seen the item, remove it from what we add in. If we haven't seen it, add it. That's the logic. That's what we wrote out. Any questions? Okay. So at this point, we're done with our for loop. We want to go ahead, and the question also says sort the end result, right? So now we have a variable given to us called scores that appear once. So we'll go ahead and say scores that appear once here equal to our unique scores dot sorted, right? So on a set, you use dot sorted on a set, it returns you an array. Okay, everybody? So be careful here. You have a set. We agree that unique scores is a set, correct? Yes, we specified it on line 16. But now, if you use dot sorted method function, we'll see functions after. If you say dot sorted on my set, it returns me an array, right? Right, which makes sense. Arrays are sorted. Sets are unsorted, right, everybody? Okay, cool. Exactly. Cool. Very good, Amini. So at this point, we have sorted our result back inside our scores that appear once, and we could actually test our code here. You have to battle to get to the promised land, right? There's no smooth road to the promised land. That's an illusion. Again, you have to be lost to be found, right? Look at the prodigal son, right? Look at the prodigal. I've been there to the promised land. Okay, yes. Last step, you have an error or you have a problem? Oh, yes, so, okay, other questions. So Yulia is asking, sorted what? Sorted ascending, sorted descending. In that question, they showed us what the sorting looks like, right? If you see in the assert, it's ascending. Ascending means from smallest to largest. So sorted, the function sorted, by default, it does ascending. It happens to be sorted here. Well, it's not exactly sorted here. That could be a question that could be a clarification question, but we were able to see the output they gave us, right? They said it's sorted, and we saw it's ascending. So at that point, if you have a question, which that's a good question, hey, this is not sorted, right? But your output says it's sorted, I get it. I got that answer. But that's a valid question for the interviewer, right? Because the array you gave me is not sorted. Cool? Okay?
So how would we, like, say that the first one was 11 and the last one was...
Well, it has to be sorted in some way, right? Because the question said at the end, it has to be sorted. So either it's sorted small to large or large to small. No, that's not sorted. Yeah, that's a ambiguity we need to fix in that question. Okay. Okay, it's unclear. It's not clear. It's not clear enough.
I mean, it's clear, but what I'm trying to say, I think it's sorted for all the cases in which the exercise.
Say that again. Sorry.
But so right now, what happened is that you left two numbers, 1 and 99.
In the order that you read it. In the order that you read it, we put it in some array. We should have it in that same order. So 199, 101, yes. So the same order in that case. Cool? In the same order that you read it in. Okay, that's what I'm saying. So in that case, we would refactor our code here and add it to the actual array that they gave us in that order. Okay? Then let me show you what that would look like. So everybody bear with me here. Actually, let's go to the answer and come back and refactor it. Is that fair? Okay. So uncomment your assert here. Uncomment your assert and let's run it. Okay, so everything passed because we had no error. Everybody with me? Okay. At this point, we have our array coming back equal to 199. So with Yulia, let's go back and refactor it because Yulia's question was, we want to add elements as we see them, right? Not using sorted on the final answer. Everybody with me? Everybody with me? Okay, so let's go ahead and refactor our code. Now we've solved the problem, but we have to go back and refactor the code. So we refactor the code. Where we insert in here, instead of inserting it into unique scores, everybody with me? Let's go ahead and insert it in our given array, which is called scores.append score. So now it adds as it sees it. Do we agree? Which it did before anyway, but it was in a set, so it unordered. So it adds as it sees it. And now our unique scores here, let's go ahead and remove from our scores here. So scores dot remove. Now we have optionals. Sets are easy to move, right? Because they're unique. So it's easy to say, hey, I want to remove score, right? It's a unique value. Now we have an array. We want to remove something out of index. We don't know what index we're in. Many ways to do it. Anybody want to volunteer? I want to remove score from my array. Yes, right now we will remove unique scores and use our given array, scores that appear once. So right now we're not dealing with a set anymore. Delete it, we're refactoring it, we're dealing with an array. How can we remove score from our array? Zara, on line 19, we added score to the array, right? Currently, yes? Now we want to remove it in our else statement, because in that case, we saw that score already. Everybody with me, right? It's refactoring Zara. The first one worked already. The first time we did it, it worked. But now we're refactoring our code, removing some variables that we don't need, right? But before it was easier to remove the score on the set, right? We say set.remove element, done. But now, on the array, we don't have the actual access to that actual element. We have to get an index to remove that element from it. Any hints here?
The way the question was, I made another word outside that, and like use I didn't remove the other set, and I used that as a filter to get the one line.
Yeah, that's fine. But right now we want to solve what we have right now. We only want to remove the value. That's all we're after. Yes, sir.
You have to go back to the ribbon and enumerate the scores value.
Okay, so Christian is saying use dot enumerated. Is that what you're saying? So Christian is saying use dot enumerated. Do you remember what dot enumerated gives us? The index, right?
And then we gotta fix the
And now we have index here. Right, everybody? You want to get index, the current index that you're looking at. Do we remember enumerated? So everything we've seen, it comes back, right? How can we do X with what we've seen before? It may look trivial, right? Just remove some item here. But how do I get access to the index? I want access to that index in order to remove it. But now we have access to the index. Everybody with me? So now I could say on my array, scores here, remove at the index. Right? And no longer do we need line 24. I'll comment it out now. Let's verify it does work before we actually remove it. And let's go ahead and run our assert again. Out of range. Because we deleted it, right? So now it doesn't exist. Right, it doesn't exist. So, what else can we do? Let's find it. Let's find where that thing is. Yeah, keep the enumerated because we need to remember how to use it. But now let's actually find what we're looking for. So we'll use optionals. We love optionals. We'll use an optional to find the index of score. Where is it? So here I will say index or found index to not have the same name. Found index equal to my scores dot first index = 1. of the score. One second. Here, one start first index of my score. Okay. So now we use our array. We say, get me the first index where score appears. It's optional. It returns as an optional. Actually, it returns as the actual index if it exists. If it does exist, now we just want to remove it. So let's do scores remove at the found index. Run the assert again. And this time it works. It found the index. A bit more work. We saw sets was easier to work with. Arrays is more complicated here, right? Because the sets, the elements are unique. It's easy to find the object you're looking for. Either it contains or it not contains. And always remember, contains on sets and contains on arrays are different. I'll put that down here again. So contains on a set is constant time, which means big O of 1, right? And contains on an array is linear time. We'll go over what that means, which is big O of n, right? Those are two different runtimes. The efficiency here, that's the efficiency of the algorithm. The runtime efficiency of the algorithm. Right? If you see big O of 1 here, again, we'll go through big O in unit 2, but that's an early glance. If you see big O here, says read as big O. If you see big O of 1 here, this is the best you could have. Everybody? This is the best runtime algorithm you could have. Contains here, it says big O of n. Basically, it means I need to go through every element in the array to find that element. Worst case scenario, I have to go through 1,000,000 objects if I have 1,000,000 items in my array. But in the set, it's constant. Get me Christian, I get Christian right away for you. I don't have to search through the entire set. Because the set, the elements are unique. That's why the constant time is, that's why the runtime is constant time here. The elements of the set is unique. Okay? Same as when you access a dictionary with the key, that's constant time. Get me a dictionary with the key score, that's constant. But contains on array is linear. Everybody with me? Okay. Yeah. But again, the earlier you could be exposed to what runtime means, the better. Do we, cool, so far so good? Yes, sir. Yes. So Mr. Jahid is saying, is that because of the hashable being elements needs to be hashable to be in a set? Yes, because that makes it unique. If it's unique, score only exists once. So the minute I do find score, I know where it is. Okay, scrolling up. When we do not use a variable name, what do? So now we're not using that index, but it's important to know how to get that index. We do underscore here. So yes, Eddie, there's different ways to do a problem, which is good, right? But you always want to see all the solutions and see where you could pick up optimizations there. We saw with sets, it was cleaner, right? We had less things to do. But with the array, we had more work to do to find the index of that particular item. Because if you remove it, the index doesn't exist. Yeah. Oh, this guy here? That's fine. No, you say that. If you don't understand, say it so we can go back over it. So let's go back to 21. No, let's go back to 21. Let's walk through it. So 21 says, I'm looking for something. I'm looking for some value, right? Get me that index of that item, right? In that case, we say first index here, get me the first instance of it, right? Get me the first index where score exists. If it doesn't exist, what do we get back? Based on the syntax we have here. If let, what does if let do? What does if let do? It unwraps a value, right? It's optional binding, right? Chelsea, what does if let do? It unwraps the value. So here, I'm searching for a value, right? That first index here. It returns us an optional. Either it did find it, in that case, an index comes back to us, or it didn't find it. In the case that, for example, if we're looking for some, like 100, does 100 exist here? It doesn't. What value should we expect back? Nil, right? Because 100, that does not exist. We don't have 100 elements here. So in that case, you could have an else to capture that, but we don't care about the else in that statement. We only care about get me the index if it exists. Right? So it makes sense for it to be an optional. Amini? It makes sense for it to be an optional because I'm not sure if that thing exists in the array. Right? Before we did not use optional, we just said, hey, the thing is there, get it for me. What happened? It crashed. Right? So here we protect ourselves, find me where score is, the score I am currently looking at, and return me the index.
So, saying basically we're doing if the number is already in the visited number, if it's already been visited,
If it's 77, for example, yeah.
then we're going to determine where the first index of it in.
Yeah, so if it's 77, for example, right? A value score is 77, right? Okay, so if we're looking for 77, for example, in that case, we hard code 77 in there. So if 77 is in the array, give me the index back. Okay, index could be 0, 1, whatever. Give me that index back. Now we have the index here, found index. Now go ahead and delete it on line 22. Matri? You want to explain to me what happened? What's happening on 21? Read me through it. We're searching for score, right? Where is it? Okay. And what's if let do? What does if let do? Yeah, in that case, it unwraps the value first index, right? And now we're able to use it in here, correct? To actually remove that element. You'll come across using if let on indexes a lot because you're looking for something in some, like you're looking for a fellow. It's in an array. Where is that index, right? I want to give that person, a birthday cake, whatever. Where is that index? I want to find that fellow. So you use optional binding here, find it. In that case, nil coalescing would not be ideal, right? You see what I'm saying? You don't have a default value to remove. You could have -1 as your default value, and if you find -1, then something went wrong. That's fine. But in that case, optional binding would be better. Everybody with me? Okay. Matt? Questions? Okay. All right, cool. Can we move on with this one? We good? Any other questions? Oh, I ran it already, right? Did we run it? We ran it. Let's run it again. Yeah, it's good. Let me select the final result here, and we'll move on to the next question. So what do we have? We have final scores. Yulia, questions? Okay, so I slacked out the solution for number 1. Let's move to question 5. Everybody ready? We good? Okay. So question 5, let's start with the question. It says, determine if a string is a pangram, right? All those questions, by the way, they're valid, interview questions. So really understand them. Okay, so determine if a string is a pangram. A pangram is a string that contains every letter of the alphabet at least once. That's the keyword there. Every letter of the alphabet, right? At least once, okay? A to Z, the entire 26 characters, at least once. Everybody with me? That's the breadth of the question here. They give us some examples, right? And we have some test cases here. So how do we start that problem? We have a string, the quick brown fox jumps over the lazy dog, right? We need to get that string in such a format that we could be like, hey, your characters should be equal to some other alphabet set. If that's equal, I'm done. Everybody with me? If all the characters in here has A to Z, it's a pangram, right? So we understand the problem. The coding part, that's where the challenge begins, right? How do we get this string in some sort of a way where we could compare it to an alphabet set, for example, right? As a human, we could look at it, we could be like, hey, maybe if we lowercase everything, remove all the white spaces, that's a good start, right? Make it a set, compare it to some other set with all the alphabets. I think that gets us where we want to be, correct? So let's see what that looks like, right? Code here. I made a short video to see how to create alphabets, right? But for the class, the purposes of this session, I will write out the alphabets. But the video does show how to use Unicode scalars to create a range of alphabets. Everybody with me? Okay, so, but for the purposes of this lesson here, or review, we'll just create alphabets here by just typing them out. So it's a set of characters so we have A, B, C, D, E, F, G, H, I, J, K, L, M, O, P, Q, R, S, T, U, W, X, Y, and Z. Right? So we have our alphabets here. How can we convert that string to a set? How can we convert that string to a set? Mr. Had.
Just do set over the whole string.
Okay. You said that with a green, like you the Grinch. Yeah, so that works, right? So Mr. Ahad is saying, go ahead and use the set initializer on the string. Everybody agree? So we cast it. Right? So we say set here, parens, close parens. Right? Everybody with me? So here I have a string, I convert it to a set. We did that with arrays, didn't we? Right? If you want to convert some string to an array, you type in array, you wrap the string in an array, and you get a set, or you get an array back. Everybody? Right? So at this point, we could actually print out what alphabets look like if we are not sure what it looks like. So I'll print out alphabets here. I'll play my playground. And look, I have a set here of alphabets. Right? They're not ordered because we know what sets are, unordered collection. But at that point, we don't really care about the order. So we're leaving it as is. So part one we have some way to compare our string, our given string, to a set of alphabets. If set A equal to set B, we are good. We saw that yesterday. So let's go ahead and continue. Great. So we'll start off with our string one. So I will say for character in string 1. Right? We want to do a couple things to our string. We want to remove, or we want to maybe add, create a new string is probably a good thing to do. Let's just go ahead and create a new string here. Call it, what's that?
String form?
String form?
Form.
Or string, I'll call it trim string for now. Right? Trim string meaning we remove all the white spaces. We only concern, or rather, that's fine. Trim string is fine. That's fine for now. We could always refactor the name. For character in string 1, what is, it says the name already. So that's a character in my string, correct? I'm iterating now. I'm using a for loop to go through my string. Every element is a character. We agree? Yes? Okay, cool. Now we have a set here. What do we know about contains? What's the runtime of contains on a set? Constant time, right? So we don't care about quadratic runtime here. We'll see more about quadratic and everything later. But that's fine, that's fine. I want to talk about it so that at some point we'll, yeah. That's fine. Not understanding it is fine right now. But it gives us like that urge, like what is the thing that we could go home and read about it. That's what I'm trying to aim here. Okay, so for char in string 1, I come in here. I want to add only valid characters to my trim string. So I'll say if char, well not char, but if alphabets dot contains this char here, right? Char is a character. My alphabets is a collection of characters. That's a valid comparison. If alphabet contains character, go ahead and add it to my trim string. Right, so trim string, how do we add? How can I add here? Append. I could append. Well, how else can I add? Insert. But this is a trim string, right? So we could just say plus equal here. String and char here. Many ways we could do it. So here we have a string, we append in the current character. We only append it if it's part of the A to Z, correct? Yes, sir. We add in, so as we loop in through the for loop. Well, on a string, it's more idiomatic to use plus equal on a string, as opposed to append. When you see append, you're thinking it's an array. Does that make sense? Right? So you'll see plus equal more in code than append. You'll see append on an array, and we could only insert on a set. We can't append on a set. Cool? But like syntactically, it looks better with this syntax, as opposed to append. Cool? All right, so let's see. So now we good with the trim string. We are good. Let's actually go ahead and print out what our trim string looks like here. So print. Again, use print statements as you code, right? Don't type your whole logic out, try to run assert and be like, hey, oh, what's happening, right? Print as you go. What's happening? The best way is to have a print statement. Debug your code as you go. What does my string look like? So let's type it out. What does string look like? If I run it here, that looks fine, that looks good, right? Right, everything is lowercase, I'm happy. So far so good? I need to lowercase my string 1 here. I observe that, run it again, make sure I have everything taken care of. Right? I have my T. We're all happy now. Right? Because string 1 had an uppercase T. Do we remember? Everybody? Look at our string 1. It has an uppercase T. It's not part of our set here. We lost it. So we need to make sure everything is lowercased. Do we agree? Okay, so now we could get our T because it's lowercased here. This is valid. You could say string 1 dot lowercased. So the collection itself is all lowercase. Everybody with me? Great. So our string 1 is good. Now we could make a comparison here. Let's take that print statement out. What's the comparison? So we have a Boolean value, string 1 is pangram, right? So let's go ahead and say string 1 is pangram. That expects some sort of condition, right? String 1 is looking for some condition. Is set 1 equal to set 2? Whatever it evaluates to, it's either true or false. So we have our alphabets, that's great. We have our set of trim string. Is that equal to our alphabets? Right? We could actually run it and see. It's true. Look at that. That guy's going to be a pangram. Right? Set equality doesn't care about order. Right? So here I have set trim string. I have my string, my regular string. Right? I cast it to a set. And I'm finding out now, is set equal to alphabets? Is it? Because remember, set gets rid of uniques, right? Everybody? I mean, gets rid of duplicates, everybody? Yes? So at this point, 26, is it equal to 26? That's what's happening here. And is every character the same? Not just the count. Is every character the same? So at this point, our playgrounds is saying us it's true. So we could go ahead and try our first assert here. Right? And run our code. I think it ran faster than I played. Let me stop and run again. Great. Everything ran. It worked. Right? So that is the solution for this part of it. Again, we won't go into string 213 because it's repetitious. We'll start looking at functions. I'm not going to write that code again twice. We'll actually come back to that one and see how to do it in functions. Actually, no. I was going to do it in functions. There's always a shorter method, but let's learn the long way, please. Let's understand fundamentals first. Okay. Because you could filter, map, do a lot of things.
There was like a superset method.
You could also superset it. If that's what you did, excellent. Ask what the question said. Use a set where you can.
Okay.
All right, cool. So, what's that? Okay. Also fine. If you have your solution, it's working for all three cases, thumbs up. Cool? Is what?
It's for each one.
Yeah, that's what I'm saying. Like, you have to do it for each one.
Yeah.
That's why we stop here.
I'm just like wondering which way is going to
Using a function, right?
I mean, like, just this part in and of itself.
For that part, using a function, put that entire thing in a function, and having an array of the strings getting passed to that function, and return if it's true or false. And you're done. Cool? All right, so we'll stop here.